Okay, so we're going to start the next theme, which is the normal distribution. Okay, so if you remember, all the distributions that we've looked up until now. So what's the first what's the first distribution that we started looking at? What's the first probability distribution we started looking at? Good, uniform. And what was a uniform distribution again? What was a uniform distribution? Good, all the probabilities were exactly the same. Good. Good. So what's another distribution? What was the next distribution we looked at? Good, binomial. What was a binomial distribution again? Good morning. What was a binomial distribution again? Two possible cases. Good, absolutely. So binomial distribution resulted in either a success or a failure. There were a fixed number of trials, and all of those trials were independent of each other. Good, fantastic. Another distribution? Poisson distribution. What was a Poisson distribution again? Sorry? Okay, so something happens at a constant rate. So, for example, your heartbeat or the number of tweets on Twitter per minute, yeah, and things like that. Good, so that was an example of a Poisson distribution. Now, all of these distributions can be described as a discrete random, or can be described by discrete random variables, okay? So uniform distribution, binomial distribution, and Poisson distribution all tend to describe discrete random variables. Now, like I sort of said last lesson, uniform is actually a bit of an outlier because it can describe both discrete and also continuous as well. Okay. So today, we're going to move on to one of the first continuous distributions. Okay, so continuous random variables, and we're going to look at the normal distribution. Now, the normal distribution is the only continuous distribution that we're going to look at in this course. There are others. Like I say, the uniform distribution can also apply to a continuous distribution, continuous random variable. Also, an exponential distribution, that's an example of a continuous random variable as well. But we'll only look at the normal distribution in this course. The reason why is because all of these things, so the binomial distribution, the Poisson distribution, and the normal distribution have very similar characteristics. And it tends to follow this kind of shape. Okay? So in other words, so this is, say, for example, the probability. And this is the outcome. Okay? In other words, there's a couple of tails. Those are the kind of extreme values, so really small, really big values, and then you've got the majority of values in the middle. And we've already seen this shape with binomial and Poisson, and this is going to continue with a normal distribution as well. Okay? So before we get there, let's just have a look and make sure that we understand what these words actually mean. Okay? So discrete random variable, I know we've done it a million times. Okay? What's a discrete random variable? Good, so it can only usually occur in integer values, so set values, right? What's a uniform distribution? We've kind of just gone through that. So uniform distribution, are you happy? Is just all values are equally likely. Binomial, either success or failure for a fixed number of trials. And then obviously you've got Poisson distribution, which means that something can happen at constant rates. That should be a reminder. Now have a look on the screen, okay? I was meaning to bring my Galton board in today. I've actually got a physical one that I can show you. However, I've forgotten it. So have a look on the screen instead. Effectively, at the start, there are a load of beads kind of holding at the top, so in the holding pen at the top. You then flip it over, and then there are a load of pegs which the balls can go down. Now you see I've drawn like these pegs on the screen. So, sorry, on the board. So basically every single time that a ball drops, it has a decision to make. So let's suppose that my pen is the ball, okay? So the ball drops from the holding pen, it then gets to this peg, and it's got a choice. It can either go left or it can go right, okay? So basically every single time it drops to the next layer. So it can either go left or it can go right, okay? Well, if it goes left, it's then at this peg here. And again, it's got another choice. It can either go left or it can go right. Okay, let's suppose in this case it goes right, then it's here, so then it's got a choice, it can either go left or go right. So every single time that the ball drops, it's got a choice to make. It either goes left or it goes right, okay? And then in the end, once it gets down here, there's different positions that that ball can be in, either here, 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 or here, okay? So basically these, if you like, are these are the bins, okay? So let's name them. This is bin 0, bin 1, bin 2, bin 3, bin 4, bin 5, and bin 6, okay? So for this particular Galton board, where there's 1, 2, 3, 4, 5, 6 rows, there are 6 bins where a ball can end up being. Now the idea is that you can see there are lots of balls to start off with. So at the moment, we're just considering one ball, okay? There's lots of balls that we can start off with, and basically the ball drops every single time, and there's 6 different positions that each ball can be in. Now, all I want you to do, and I'm going to give you sort of 5-10 minutes to have a go at this, I want you to find the number of different paths that a ball can take to get into each bin, okay? The number of different paths. So as an example, let's get rid of all this. Let's see a possible path that we can take to get to this bin. Let's see a possible path that we can take to get to this bin. So we could go left, then left again, then left again, then left again, and then left again, and then right. Okay? So that's one possible path that we could take. Yeah? Another possible path that we could take would be to go, well, let's see, right, then left, then left, then left, then left, then left. That would be another possible path. Does that make sense? You've just got to work out how many different possible paths you can take to get into each bin. So can I give you 10 minutes, maybe make a quick diagram, sketch something out very, very similar to this. All I want you to do is just work out the number of possible paths that you can take to get to each bin. Now just remember, the rules are that a ball has to drop a row. So every time the ball has to drop a row, okay, it can't go across, has to go down, and it can either go left or right. Is that okay? Yeah, morning. So can I give you 5-10 minutes to have a go at that? Just work out all the different possible number of paths that you can take to get into each bin. Okay, shall we have a look at an example? I've taken it back a couple of rows because I think it might be easier to look at 4, and then we can apply it to sort of 6, which is on the screen. Okay. So let's see. I want to find the number of ways to get into bin 0. Bearing in mind I can only go left or right each time. How many different paths can I take to get to bin 0? 1, yeah? So I literally just have to go full lefts. So I do left in blue and right in red. Okay, so I just have to go left, 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 and then left again. Make sense? Okay. And there's no other ways of getting into bin 0. You happy? Okay. So now, how many different ways are there of getting into bin 1? Let's count it. So you can go left, 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 and then you'd have to go right at the last minute. Yeah? So you'd have to go left, 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 right. Okay. How else could you go? Okay? Okay, so left, then when you're here, you're going to go right, and then you're here, so you must have to go left at the last minute, yeah? Does that make sense? Yeah? So you go left, left, then a right, then a left, okay? How else? Yeah, so left, left, then right, okay? And then left and left, I agree with that. Okay, so you're here, so you have to go left, then you have to go left again. So you have to go left, right, left, and then left again. Fantastic, okay. Any other ways? Any other ways of getting into that bin? Yeah, absolutely. So go right first and then do full lefts. So you'd have to go left, left, and then left again. Okay. Are there any other ways of getting into that bin? No, I don't think so. Okay, so I think that's our only options. That's our only options. Okay. So in other words, to get into bin 1, you'd have to perform at least one right and then all of the rest are lefts. Okay, so one right and all of the lefts are lefts. Yeah? So there's no other way of getting into bin 1. The only way of getting into bin 1 is if you perform one right. Make sense? Okay. How can we get to bin 2 then? Give me a possible path. There is, but can you give me all the different possible paths to get there? Okay, so left, 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 and then a right. Wait, what? Two left, sorry. So left, left, then a right, and then you'd have to go right again. Okay, so left, left, and then right, right. Okay, how else? Okay, so left, right, that would totally work. So left, right, how else? What about left, right, left, that would work as well. How else? Okay, so right, left. Okay, we're going to go right, left, that's fine. How else? Right, left, left, right. Any other ways? Okay, I agree with that. Right, right, left, left. Are there any other ways? Are there any we've missed? No, I think that's all of them. Fantastic, okay. Now what about bin 3? There's 4 different ways. Can you list them to me? Okay, right, 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 left. Good. Any other ways? Right, right, left, right. Any other ways? Right, left, right, right. Any other ways? Left, right, right, right. Good. Now you should have noticed similarity between this one and this one. What's the difference? It's exactly the same thing, except instead of taking a left, you now take a right, and instead of taking a right, you now take a left. Okay? Right. How many different ways are there of getting into bin 4? Right. Or rights all the way down. Okay? So you notice for this particular example, I've got 1, 2, 3, 4 different rows. Okay? So I have 4 rows. I have 4 different rows. I've listed all of the different possible ways of getting into each bin. Okay? So in this case, there's 1 way to get into bin 0, 4 ways to get into bin 1, 6 ways of getting to bin 2, 4 ways of getting to bin 3, and 1 way of getting to bin 4. Does that make sense?